All right, folks, so I'm going to go ahead and get going. My name is Kevin Wally. I am a program manager on the Windows team. I've spent the last several years working on notifications and tiles. And today I'm going to talk to you about how to make your app alive with activity using tiles and notifications. So the key here really, the thing that we want to talk about is how users are going to perceive your app when they're not inside your app. How are users going to look at your app and say, how do I want to get back into that app? What's going on inside of that app? Because the tile is the front door to your app. It's a big surface that you can draw on, and you can put anything you want there. Now, of course, we've got recommendations. We've got ideas about what that tile should look like. But your users are going to see your tile as an extension of your application. And so this talk is largely about how you should think about that tile as an extension of your application. And so today, we're going to talk about the start screen. We're going to talk about tiles. Now, I'm sure all of you have seen the start screen before. I kind of love this because I can see what's going on in my life. I can see what news stories are going on. I can see how the stock market's doing, which I like showing this today because the stock market's actually doing pretty good. I can see that my wife wants to know when I'm being home for dinner, which is nice. But this gives me an idea of what's going on in my world, what's going on inside these apps. And this is how I make a choice on what apps I'm going to launch. So when I click on one of those tiles, I get into one of my apps. Now, what is a tile? What makes up the tile? At a very basic level, a tile is just a large icon. It's a picture that represents your app. It can come in a couple of sizes. They can be square, the smaller size, and wide. And it's up to you as a developer what size you make your tile. Both tile sizes can have updates. Both of them can have notifications sent to them. So when we talk about the tile is just the space here. And when we talk about notifications, notifications are the updates that actually change the content on the tile. Users use your tile to launch your app. When they tap on your tile, users are going to expect to launch into your app at the home page or the last thing they were doing. Notice that there's not a link between the content that has been updated on the tile and where the app goes from a basic tile perspective. So this leads you to one of our key pieces of advice, which is that your application, when it launches from the tile, should always go to the home page of the app and should always show something that's relevant to the thing that's on the tile. So, for example, on that news app, when I click the news tile, I'll go ahead and show that. There's an article going on right now. And so if I click on that app, I'm going to go to that app, and it's going to update, and it's going to show me something related to that tile. That's something that we encourage you to do. Now, it doesn't have to be a full bleed image that says something all about what's going on in that tile, but it should be, that content that's shown should be available. Go back to the slides there. So how do the tiles get updated? The tiles are updated using XML templates. These templates are predefined by the operating system. Your app just supplies the content that goes inside of those templates. There's a rich catalog of templates. You can find them on MSDN. I'll show you some examples of them in a moment. These templates can include images. They can include text. They can include both. They give you a lot of freedom to display content on your tile, but still making it look rich and look beautiful in the context of everything else that's on the start screen. The reason we use a template model is so that users can easily scan through the collection of information that's on your start screen and easily pick out the information they want to see. And the templates aid in that. It also makes it easy for you, because then you can just, if you want to do the simplest thing possible, you can put text on a tile, which is just adding string to a predefined template. If you do choose to use images, the images can be JPEGs, PNGs, or GIFs, and the max size is 200 kilobytes. Also, there's a max pixel size. The max pixel size is 1024 by 1024. The reason I bring that up is that if you include images on your tiles, those images can be part of your package. They can be downloaded from the web, but they have to conform to those limits. If they don't conform to those limits, we actually won't show the tile. So this is one of those pro tip debug things. The first time you go to implement tiles, if you're finding that you're sending a tile notification, it's not working, you're trying to figure out what's going on, the first thing to do is check the image sizes if you're including images, and check the actual image types. And don't rely just on the extensions, because we often find that people put extensions on image files that don't actually match the actual type of file that it is. You need to open it up in a photo editor and see what it really is. Generally, when people are getting going on developing notifications, our recommendation is to start with text only first. That way you can figure out what's going on in the easiest way, and then add text or add image templates in later on. Tiles also have something that we call peak templates. In the collection of templates that we have, some of those templates animate and some of them don't. The ones that animate, we call peak templates, and I'll show you some examples of that in a second. And then later on in the talk, we'll talk about how to update notifications. There's different ways that we can actually update them. So let's look at some templates. So this is a smattering of the templates that we have available to us. Some are text, some have images. If you look up here at the top, this is a template that just has images. I'd like to point out the badges, these numbers that are on the tile. These are updated similarly to the way that we're going to talk about tiles, but they're updated separately. So sending a badge update is actually really easy, so we're going to focus mostly on updating the tile. I only bring it up to call out that the tile update and the badge update are actually separate things. You don't update them at the same time. So going back to the templates, this is a template that just points to an image that gets downloaded and shown on the tile. This one is an example of 5 different images on the same tile. So you give us 5 different images, we put them in the locations that you specify in that template. And this is an example of having text and images at the same time. When I talk about peak templates animate. So this is an example of a peak template. When the timing basically kicks off, the content rolls up and rolls back. So let's see that again. So you can see a number of these actually animate. The peak templates give you an opportunity to put more content in the same notification than can actually be displayed in that physical space. So I can have one big image and a big block of text, and those 2 frames will animate back and forth. So that's something to keep in mind when you're looking at designing your notification experience, to think about what kind of content you want to show on your tile. Is your image something that the users are really going to recognize, and is there text associated with it, and should you link those 2 things together, versus sending separate notifications for separate pieces of content. One thing to call out is that peak templates, we see people often want to put things like their application's logo and then some text related to the notification. We advise against that because users, when they see your app logo, are going to think that the tile's dead. They're going to think that there's nothing updated there because it's just your app. What you really want to do is either show the text related to that notification, that data, or show an image that's related to that text. But showing your app logo doesn't actually help the user decide if they want to launch your app or not. If you'll notice, a lot of the tiles have different content down lower left-hand corner. This is basically your branding. So either the Flights app here has put the word Flights, this app here has put its app logo. That's how users are going to actually identify what the app is. So enough talking, let's look at some code. So I'm going to take a look at the tile sample here. This is the sample that's available in the SDK. One thing I want to call out is the app manifest and how the app manifest relates to your tile. Before I said it's up to you whether or not you choose a small square tile by default or a wide tile. Your app manifest is where that's decided. So here where you have your logo, you have to supply a square 150 by 150 image. That's your base tile. That's what your application is going to look like when your user first installs it, before your application gets run, before you update your notifications. You can optionally supply the wide logo. The wide logo is the one that, if you supply that, it tells the Windows operating system that, hey, this tile can be updated in the wide format, and we can let the user actually make it wide. So what I didn't show you before when I was showing the start screen is that these notifications can be made smaller by the user. So if I click here, I can make that app smaller, but it still updates. Users do this because they want to pack a lot of information into their start screen. They want to optimize their space. If they don't find your notifications interesting or useful, but they still want to launch your app frequently, they're more likely to make it smaller but still keep it on their start screen. You still want to make that tile live though. So notice here, even though that this thing is smaller, I'm still getting that data. So I'm going to go ahead and launch this app, and I'm going to show you what happens. So I'm going to click this button here, pretty simple. And this tile here that's installed, because I clicked it, it updated its notification. So let me do that again. Easiest way to do that in demo is to uninstall it. So I'm going to go and run that app again. This time, let me take a look at Start here. This is the default tile for this application. It just shows the Windows SDK. When I click that button to update, it's actually going to update with the tile notification data. So let's look at the code that does that. So this is the function that gets invoked when I hit that button. Now, I've actually changed this for this demo. This is not what's shown in the SDK. I changed this because I want to show you that there's different ways that you can actually update your tile. I told you that the templates are represented by XML. In this case, I did something that I think is kind of ugly. I just typed out big strings of XML. Now, as a developer, I actually find this kind of hard to do. It's easy to screw up. You know, there's a lot of reasons. But I just wanted to show you that you can do this. You can actually take a string of XML, load it into a DOM object, and then create your notification. So in this case, I create a tile notification using that XML, and then I send it to the tile update manager and call the update function. It's pretty straightforward from the local side. What I actually want to show you, though, is something that we've provided in the SDK, which is the notifications extensions. This makes it just a little bit easier to author your notifications. It avoids having to manipulate the XML, makes it a little bit faster if you're writing local notifications. So the notification extensions is great because it gives me the ability to use a factory to create the tiles and basically have something that pre-populates that XML for me. So in this case, I want to create a wide template tile. And I've already looked at the template catalog. I know that I want this particular template. But if you noticed in the IntelliSense there's a lot of different templates that you can choose from. This just gives you an easy accessor to those. And then after I've created that, I can do the easy thing and find the different pieces that I want to add to this tile. So in this case, it lists that I have a piece of text that is a heading, which means it's larger text and it wraps. So I create that, and then to actually update the tile, I take the tile update manager and I create a tile updater, and I call update. And in this case, I'm going to grab that tile content and create a notification out of it. So I'm going to hit go here, and it's going to fail. That's on purpose. So go launch the app, and I'm going to go try to update. And I get a big error message. What this error message is telling me is that I forgot to include the square content. So remember before I was telling you that since the user can resize the tile at any time, this is one of the nicer things about the notifications extension. It does some error checking for you. Like if you forget to include the square content, it'll basically break and warn you about it. So let's go back in there and actually add that square content. So I basically do the same thing I did here. I'm just going to cut and paste here, make my life a little bit easier. But in this case, instead of creating a wide tile, let's do text. Else if I type it right. And for this guy, I should probably give it a better name. In this case, it has a text element called text body wrap. And then after I've created that, I just need to attach that to my original tile content. let's stop that and restart. Square and wide, correct. So the question was, are those the only two sizes that are supported? And that is correct. So there's my wide tile that was updated, and then go smaller. And there's my smaller notification. So that's just one way that you can update your tiles. We're going to talk more about the other ways you can update your tile. But I want to show that quick demo. Notification queuing is something else that we allow on the tiles. If you'll notice, a lot of the tiles are static. They have an update, but that content actually doesn't change. It doesn't animate around. So I don't have a peak template, so it's just sitting there. A good example of that is my chat application there right now. There's nothing changing there. It's just the last message that I missed from my wife. Or another example is the weather app. That one doesn't rotate either. It just shows the weather in my current location. However, some of those apps do change. I can see that my news and my finance and my travel app, they're showing different content and they're rotating around. For example, the finance app is showing NASDAQ, it's showing Dow, it's showing a news story related to finance. How we do that is by enabling notification queuing. This is something that's off by default, but you can enable in your app. It's a single API call. And what that does is it tells the system to hold on to the last 5 notifications that you've sent. The system takes care of animating those in, rotating them around. It's not something that your app has to do anything besides call the API call. And then from that point forward, any notification you send will get queued up. By default, it's a FIFO replacement policy. So the order in which the machine receives the notifications, it'll replace the oldest ones first. And so as those ones come in, they just rotate around. It gives you the opportunity to put more content on that tile to draw your user back into your app. Another thing I want to point to is secondary tiles. Secondary tiles are also, you'll see them in apps as pin tiles. In many apps, you have the opportunity to pin additional content to start. So I'm going to use the finance app to show what that looks like. So in the finance app, if I go to my watch list, there's 5 stocks that I care about. The finance app gives me a button down here to pin my watch list. If I click that, I get this dialog box that pops up. This is a system-drawn dialog box. The reason I call this out is that there's no way that you can pin a tile to start without asking the user's permission. So there's no way to automatically do this. You can't litter the start screen of a user with a bunch of tiles. You have to ask the user's permission all the time, because we want the user to be in control of what goes on their start screen. They really care about what's there, what order it is, so you have to ask their permission. This is that permission box. You as a developer provide that image that goes in there. So what this looks like here, you provide this example text. So in my case, it says watch list top 5. But if I wanted to, I could rename that. And then when I click pin to start, that tile gets pinned to the start. So now if I go back to start, I can see my watch list there. And now that app has told the service to start updating that tile with the actual watch list. So those top 5 stocks are the 5 stocks you're going to see rotate through here on this tile, because this tile also has notification queuing enabled. So this secondary tile can have can do all of the things that the regular tile does. So for example, if I want to make it smaller, I can make it smaller, and I can see the updates that go along with that. So let's go back to the presentation there. One thing that I wanted to call out about the secondary tiles is that they're a little bit different than the main tile, in that when you click on a secondary tile, the expectation is that you launch into that part of the application. So in your main tile, when you click on it, you always want to go to either the home page or the last thing the user was doing. For your secondary tiles, you actually want to tie meaning to them. You want to direct the user back to that place. So if I was somewhere else in the app and I go to the start and I click the watch list, it should take me back to that watch list screen. Sorry, there's a question?
Yes, for a pacing issue, password get
Yeah, so the question is, one, what's the replacement policy on the queue and pacing essentially? Like, how does that timing work essentially? Under the covers, the way your app should treat the notification queue is literally like a FIFO queue. So first one in, first one out. In terms of what order they're displayed in to the user, however, you can't rely on that. And the reason you can't rely on that is that we try to show the user the most recent thing that has arrived. So if you send a new update and it's in the back of the queue, we try to show that to the user first, because that's arguably the most recent content. So the replacement policy is different from the viewing policy, is the key point there. Another thing to call out is that there is a mechanism that we call tagging that allows you to override this FIFO queue. This is what the finance app does. If we had a FIFO queue and let's say Microsoft stock updated, then you got 3M, then you got 3M, and then Microsoft updated again, it'd be bad if I was rotating through old stock prices and new stock prices for the same stock. It'd just look weird. Tagging gives you the ability to tie a meaning to each of the individual notifications and tell us to replace the previous ones when they come in. So if I tag the Microsoft notification with MSFT and a new one comes in with is also tagged MSFT, we just overwrite the old one. So that gives you some control of that replacement behavior, but it still doesn't give you control over the order in which things are viewed. That's completely up to the system. So we already demoed that. The next thing I'm going to talk about is toast notifications. Toast notifications are actually quite similar to tiles in that their mechanism and how they're built is the same. They use essentially the same APIs. They use the same or similar XML schema. The difference is that Toast can interrupt the user any place that they're at. So Toast this is one of those with great power comes great responsibility things. If you've asked your user to send Toast notifications to them, you have the potential to annoy them. If you're popping up Toast notifications on a very frequent basis, your users are going to be kind of mad at you. In fact, they're probably going to turn off your notifications. We've given users the ability to both shut off notifications for an individual app, as well as shut off notifications for the entire system. So I'll just show you how easy that is to shut off. If I go here to settings, this notification button here, that lets me hide the Toast notifications for an hour or 8 hours. This is great for presenting. If I wasn't actually going to show you Toast notifications right now, I'd actually have this turned on because I wouldn't want to be interrupted by somebody popping up Toast notifications while I'm giving a talk. But since I am showing you Toast, I can't really do that. Toasts are similar to secondary tiles in that they have the ability to set a launch context. So when you tap on that Toast, it should take you to the thing that the Toast was telling you about. So let's say you sent me an IM message. When I tap on that Toast that says, Kevin wants to chat with you, it should take you to that chat window straight away. It shouldn't take you to the front page of the app. The best Toasts, by the way, are the ones that are personally relevant, the ones that are time sensitive, the things that people will be happy to see get toasted to them. Our general recommendation is not to turn Toast on by default in your app unless it's very clear that your app's mission in life is to send Toast notifications. Otherwise, you should ask your users permission. You should put settings in. A good example of this is the Mail app. A Mail app should actually not toast when incoming mail comes in, but ask the user instead. Make that a setting inside of the application so the user feels empowered. So let's take a look at the templates real quick. The templates are very simple, or similar to the tile templates. There's fewer of them. There's some image templates. There's some non-image templates. Notice that the color on these tiles is the app color that you set in your manifest. We do this so that users are going to tie the color that you provided with your app to the toast that gets seen. Because keep in mind, these toasts are going to interrupt the user while they're doing other things. So they're going to want to quickly identify who's toasting them. So your app icon is going to be shown there, and your color is going to be shown there. The rest of it is controlled by you. So the text and the images, that's all up to your application. So let's show a quick demo here. What I'm going to do here is show the scheduled toast notification sample. The scheduled notifications give you the ability to call a local API call and schedule something to happen in the future. So it's similar to the local notifications. The only difference is that you get to set a time for which the thing shows up. This works for tiles and for Toast. I'm just going to demo Toast to you. So how this works, I'm just going to go ahead and launch the app here. So I can, the way the SDK sample is set up, I just tell how many seconds in advance I want to see this toast. So I'm going to show this toast in 5 minutes. And I'm going to say, hello to the developers. So I'm going to schedule that. And then I'm going to go back to my app. And what I want to show you is that when that toast pops up, it pops up no matter where I'm at. It pops up on the desktop. It pops up over my MetroStyle apps. And if I click that toast, it takes me back to the application. So it's just another launch point. We want to take a look at the code here. This is using notifications extensions again. So it's grabbing some toast content from the toast content factory. I'm adding the text into the heading and the body. And then when I go to schedule it, this is how it's different from the local side. Here, I give the XML and I give it a due time. The due time is just the time when you want it to show up. Now, of course, we provide the required APIs to look and index and see what things have been scheduled in advance. So if you, from your application, you want to find out what's the list of toast I already have scheduled, you can index into that. And of course, you can delete previous notifications that you've scheduled in the future and now you want to get rid of. Scheduled notifications, honestly, are great for one type of application in its scheduling. Maybe alarm clock applications, but that's where they're really powerful. Most applications really won't make use of them, but it's something to be aware of. So now that we've talked about Toast and what the UX looks like, now that we've talked about tiles and what the UX looks like there, seen some examples, now I want to talk through the other two notification delivery mechanisms, periodic and push. So we've seen local. Local let you call an API from your running application and update your tile. Scheduled lets you call an API from your running application and schedule something in the future. But remember, the thing that we want you to do with your tiles, and the biggest benefit from your tile, is making it alive with activity while your app's not running. The best way to do that is to send information from the cloud. Periodic notifications are the easiest from the client perspective in terms of how to set them up. And they might arguably be easier from a service perspective. That's up for you to decide. Push notifications give you much more freedom and control, though. You have much more control over when things show up. And we'll talk about some of those pros and cons as we go forward. So first, let's talk about periodic notifications. Periodic notifications are just polling. It gives you the ability from your application to go to my periodic notification example. It gives you the opportunity from your application to give Windows a URI that points to the content on the web that you want to update the tile with. In this case, what you're pointing to is actually the XML that represents the notification. So in this case, I'm going to go ahead and do a couple things here. One, I'm going to grab a URI here. I'm going to run this application again. Again, this is the SDK sample for push and periodic notifications. If I go to the scenario here for polling, and I give a URI that points to some tile XML, I can choose to have it poll on a different basis, so every half hour, hourly, et cetera. And I can tell it to go ahead and start polling. And here I see my notification there. It's going to go ahead and poll. Oh, sorry, pointing to the wrong one. There's my push sample there that just polled. So let me go ahead and install that. Let me show that again. So there's my tile there. Now, one thing I want to call out is when I hit that button, what's happening is the Start Periodic Update API is being called. This is super useful to recognize when you're debugging and also when you're developing your app, how to design where this API gets called. As soon as you call the API, we do the poll. This lets you test out polling in a very easy way. You don't have to call the API and then wait a half an hour for it to actually poll. We'll poll immediately as soon as you call the API. There's no harm in calling it every time your app launches. In fact, that's our recommendation. The reason we want you to poll when your app launches is that's the best way to get your tile up to date when the user expects it to. So if you're polling every half hour and something had just changed, when the user launches the app and sees that change in the app, you want to make sure that when they exit the application, the content has been updated on the tile. By calling the polling API when you launch your app, that'll accomplish that goal for you. The other thing I want to call out is that just like the other mechanisms, the periodic APIs allow you to provide more than one piece of notification content. So since we're polling and since we're going to do it on a regular interval, we provide you the ability to provide 5 different URIs for us to poll every half hour. So let me put in a different URI here. So here I'm going to pull 2 different pieces of content. One is this hello world. The second one is a peak template. So that peak template's going to go reference the image, download the image, and it's going to show the image. And then in a minute, it's going to animate up and show the text that's associated with that. So that's a peak template. And notice that I only have 2 notifications there, but it looks like there might be 3 pieces of content. That's because the peak template represents those 2 different frames that have been linked together. And of course, when I provide that content, I can make it supply both the small and the wide template. Just to show you what the URI looks like, or sorry, the content behind the URI. So that's what I'm actually polling. That's what my service is returning. It's just a little block of XML. Now, what we recommend is that your service doesn't just host a static file, but the thing that's behind that URI is actually some sort of logic that updates the content that gets retrieved from that URI. However you do that, that's up to you and how you build your service. But this allows you the ability to have one reference point, and basically after you tell us to pull that URI, we'll keep polling that forever. And all you have to do is change the content behind that URI, and we'll update the tile for you. What's great about this is that you don't actually have to worry about things like if the machine's offline, if you missed a polling interval, if there was no network when polling was supposed to happen. We take care of all of that. So when network comes back, we poll immediately. When the user reboots their machine, we take care of polling again if we missed a polling interval. Those sort of things. And also, we try to optimize it so that if the user has no chance of seeing the content that we would have polled, we try to we back off polling so you don't get your service being hit all the time from users who aren't actually seeing your content. So we try to be aware of that for you. And so let's go back to the, there's my desktop. There's my desktop. To show you what that looks like, the code inside of the SDK sample is easy to read, just hard to show on a slide. What I want to show here is that it's a very few lines of code. You basically provide the URI, you tell what recurrence you want it to be pulled at, and then you call start periodic update. The only difference between the notification queue version and the non-notification queue version is that start periodic batch is the API call, and it takes more than one URI. So that should be pretty straightforward. Next, we're going to talk about push notifications. Now, this is a pretty deep topic. I'm going to give a high-level overview, but I encourage you to take a look at the MSDN docs to learn the details of it. On the surface, the push notification service gives you the ability to direct notifications, both tiles, badges, toast, to a user at any moment in time. It lets you address an individual user with content. This is different from periodic because periodic is really, it's kind of more around broad content. Your service will probably provide 1 or 2 or maybe a handful of URIs for different content that could be pulled. But push lets you target individuals. It lets you send messages like, so-and-so wrote on your social networking wall, or you missed a phone call from so-and-so. That's where push is really fantastic. By being in the Windows App Store, you get to use the Windows notification service for free. That's just something you get. We don't charge for it. And we take care of the scalability for you. And I'll show you how the system is architected in a minute. But the basics here are that you have to worry about the content you push out and the connections between your application and your service. You don't have to worry about keeping an active connection to all of your clients that aren't running at any moment in time. So from a high level, I've got my Windows 8 client over here. When your application runs, it will call an API that requests a channel. The channel is a URI. It represents the right to send a notification to a particular user on a particular machine. So for example, if I call the API from this machine and I call it from a different machine, I'm going to get two different URIs that represent those two different machines in my individual logged in user. If there's more than one user on this machine, every user who runs it will get a different URI to represent that user on this machine. That leaves it up to you as an application developer to decide how to associate those channels you get with the users in your application. So let's say I have a sporting app and I pinned a secondary tile for my favorite team. That secondary tile for my favorite team will get a URI when I call the API against that tile. I take that URI and I send it up to my cloud service. When I do that, that URI that I send to my cloud service needs to be associated with something. In this case, if I'm talking about a sporting app that I pinned a secondary tile to, I'm going to want to associate that URI with that sporting team that is actually pinned to the tile. My service then has to store that association, has to store the channel, has to store what that channel means, so that later on when it wants to send a notification, it knows who to send it to. So let's say I want to go and send. The first step I need to authenticate myself to the Windows Push Notification Service. We'll talk a little in a minute about how that authentication works. And then I do an HTTP post to the URI that I want to send that content to. So in this case, I do a post that says, my team just won the World Series or whatever I'm watching, or the current sports score that's going on. The Windows Notification Service receives that notification, that XML payload, and takes care of the storing and the forwarding. So if the client isn't online at the moment, it'll hang on to that notification until the client does come back online and deliver that tile. Tiles and toasts are a little bit different. For tiles, we take care of queuing them because the assumption is the tile content is going to be relevant later on for the most part. With respect to toast, if the client's not online, we drop it because toasts are supposed to be immediate. It wouldn't make sense to log back onto your machine and to get a flood of toast for things that happened in the past that were supposed to be real time, but actually happened 2 days ago. And so that's pretty much the basics there. Registering your app, this is something that will actually be part of the App Store once you have access to the App Store. Right now, in order to give you access to the push notification service, we've set up this site, this manage.dev.live.com/build. This gives you the ability to go and register your application to use the push notification service. I'll show this link later on in the talk if you don't want to write it down right now. When you go to this site, you'll log in and you'll provide your package name, your application name. You'll provide your publisher. These are things that have to match up with what's inside of your application. And once you do that, we'll give you a package name, we'll give you a client secret, and a security identifier. The package name, that has to be what is in your, go back here. This package name is what has to match up inside your application package. So if I go back to my tiles example here. If I go to the manifest and I go into packaging, there is the package name, thank you. So this package name has to line up with what's provided in the build site. When you submit your application to the store, those two things have to match up as well. It's just a little bit easier when you go through the store. This client secret and the security identifier, those are the pieces of information that your service in the cloud are going to need to hold on to. This client secret is a secret. Don't publish it. Don't put it somewhere on the web. Make sure you hold it tight to your chest. You might want to make sure only a few people have access to it in your organization. This security secret gives you the ability to send notifications to a particular set of channels that are tied to this application. If this package name and this client secret, if these things don't line up, you're not going to be able to push notifications. So in terms of building a service, so we talked about what a service does. It has to request channels, it's got to register at the cloud service, it's got to authenticate. This is something you can build on your own. If you already have a standing service, you can integrate this into your service. If you don't, I want to show you the Windows Azure Toolkit, which is a standalone, it's a solution that's already prepackaged that you can use to get a cloud service up and running relatively quickly. So what this service does is it provides you the secure API to take those channels from your client application and send it up to the service. This is a strong recommendation that when you communicate your channels from your client application to your service, that you do so over a secure channel. That way nobody can get access to the channels that you're sending up, because again, you want to protect your tile. You don't want other people to be able to stomp on it. It gives you the ability to persistently store the URIs. So you have to have some sort of storage on your service and management there for replacement when those channels are re-requested. And storing of the images. So if you're going to host images that are associated with your content, you need to put them somewhere on the web. This does that for you. So in Azure, how that's built out, it uses Azure Compute using Windows Azure websites and the web API, and it uses blob and table storage. I'll just demo the way this works just real quickly here. So So first, one thing I want to show you is that in the package manifest, this solution that comes with the Windows Azure Toolkit, it has both a client application and the backend included with it. If I look at the client application and look at the package manifest, you'll notice that the package name here, this has to match up with the app that I registered. So that's good there. And if I look at the web configuration under the, you'll see that you have a place to place in the package SID as well as the client secret. So if you download and use this toolkit, those are the things you're going to have to do. You'll have to register your app. You'll have to replace these things in the toolkit so you can actually use this. So I just want to show you where those are at. So let me go ahead and start the back end. Now this I'm going to run locally just to save me the 30 seconds of having to go and deploy it. So I run this locally. It's running on my local box. It's going to go to localhost here. Now it brings up the localhost web page, and I'm going to log into it. So I'm logged in now. And now I'm going to go and kick off the client app. So this launches my client app. We'll see that I've got a tile here that represents the app. And from that app, I'm going to call register. So that register call actually does the channel request from the notifications system locally on the machine. It takes that channel and then uses the Azure Secure API that's provided in the project to send that channel up to my notifications service that, in this case, is running locally on my machine, but ostensibly would be in the cloud. So if I go back to the portal here, I go to push notifications. Inevitably, something has to happen in a demo, right? There we go. So here I have my application ID that was sent along with the API call, and here's the channel that was requested. So I got that in my database. One thing I want to point out here is that channels have expiration. So the Azure service keeps track of the notification channel expiration. When your application calls request channel, it's going to get a channel back that's in the URI. It's also going to get an expiration date. Right now it's 30 days. So that channel gives you the ability to send push notifications for 30 days to that particular endpoint. Your application has to run again to request a new channel to get a longer expiration date. We do this so that you can be sure that when you're sending notifications, you're not wasting your effort, that your application is still there, that somebody hasn't uninstalled it, that it hasn't gone away. This gives you, but what this means is that your application has to take the responsibility to request a new channel and send that new channel up to your service on a regular basis. This is typically done just by launching the app. Our recommendation is that when you launch the app, you request a new channel, you send it up to your service. We recommend that you build in a little bit of fail-safe logic there so that if, for example, you can't reach your service at that moment in time, that you back off and do a retry, wait 10 seconds, try 3 times, and see if you can get that channel up. But use that application launch as an indication that the user is still using your app and to go and update your channel in the cloud. So I'm going to use the project here to send a notification. So in this case, I'm going to send let's send a toast. And here you'll see that I've got all the toast templates here. They're built into the project. So I'm going to send that notification. And you'll see that notification pop up here. And if I click on that, it'll switch me back to my application, just like the scheduled notifications did before. Of course, I can send tile notifications as well. Let's not do a peak. Let's just do a wide image. So I send that. I also want to point out that when you send a notification to the cloud APIs, you actually get status back. It'll tell you if it was sent okay or if there was a problem, and it will tell you information about, like, if, for example, your authentication failed. So you can use those error codes to diagnose issues. Pay attention to them. We encourage you when you're first building things out to have some logging on to keep track of those errors, so that if you start encountering issues, you can go through your logs and see what's going on with your service. And MSDN has a pretty good list of all of the error codes that can come back and what you can do about them. So if you encounter something, you can go and figure out what's going on in your application. So if I go back to start here, I can see that notification that I pushed down, got an image and the text that I just sent. So how I'd like to wrap up is to just talk about some tips, some advice that we've learned from helping folks implement their applications. We get often asked questions around, well, when should I update my tile or my toast, and what should I not do? So I want to talk a little bit about that. The first thing I want to talk about is when should you? You should send personalized and real-time status. This is the best type of notification. It's generally best sent via push. It can be done using periodic, but push notifications are the best way to send personalized things. So somebody Hello? Oh, that one works. Here, let's hide that one. All right, thank you for letting me know. So the second type is subscribe content, things that users have said that they care about. So for example, pinning a tile is a way to say that I care about something. So going back to my sports application, if I say that I care about a particular sports team, that's a great thing to send. So in particular, things like ongoing sports scores, because if I care about the team, I'm going to want to know about a game that's in play, so seeing the actual score of the game, which in soccer would not actually change that fast. Other examples, we talked about updating things at application launch. Application launch is a good time to update your tile. It gives you it's basically the best place to make sure that the content in your app that's being shown lines up with what's being shown on the tile, so that when a user exits your app, they feel like that tile is up to date as a part of your app. Another place is when you launch an app, so like that messaging app I have, if I were to tap on that tile, it's actually going to clear out the missed message that I had and the missed number of chat conversations. That way, when I go back, I feel like the application responded to me going and looking at things and saying, oh, well, I've read all those conversations. For non-personalized content, things like stock updates and weather, doing polling and periodic is a great way to do it. This is content that users care about, but if they really want to know the most real-time, up-to-date status of things, they're actually going to launch your app. I tend to think of the stock tile as a good example here. day traders aren't going to rely on your stock tile to find out what's going on in the market. They're going to launch your app, hopefully. And that's where you want them. You want them to launch into your app. The tile is just the front door. And of course, we talked about missed toast notifications, like missed phone calls. So how should you not update your app? We strongly recommend that you avoid streaming high-frequency updates. People aren't going to sit at the start screen and wait for the tile to update. They're going to launch your app, and that's where you want them. The tile is just an enticement. It's a way to light up your application and get them back into your app. So we encourage you to avoid streaming content to it. Don't clear your tile when the app launches or exits. Of course, the example of the messaging app, it runs opposite of this. But in most cases, you don't want to clear the content out on your tile and make it look dead, because then users aren't going to be drawn back into your app. You want it to be alive. Don't update to explicitly replace old content. This is something that we see people do. They say, oh, well, I sent some content, and that content is going to not be valid tomorrow, so I need to make sure I have something to send tomorrow. Well, you don't have to do that. We have a concept called expiration that you can attach to each notification that gives a notification a time to live. So I can say, well, for example, I have a daily deal site, and I have a tile for my application. And that deal site updates every morning at 8 a.m. And those deals are only valid until midnight that night. When I send that notification, I should set the expiration on that tile for midnight, so that when midnight comes around, the tile notification gets pulled off the tile, and you don't have to take any other action. Windows takes care of that for you. The other thing about expiration that I'll mention is that local notifications don't expire. So if you send something locally, by default, they don't expire, but of course you can set an expiration on them. Things from the cloud, so push notifications and pull those. So this is one of those things that if you don't remember, you'll find out that people report, hey, my tile went dead. When you'd updated it, it was there, and the content disappeared. If you see that happening, check your expiration and make sure the expiration is long enough for your purposes. Finally, we talked about this before with notification queuing. Don't rely on the tile ordering. They can get out of order. If you're sending things over the internet, things can get in front of one another. And when we display them to the user anyway, we don't lock them into a particular order. So to recap, I want to encourage you to think about how your tile is going to be part of your application. Think about how users are going to be drawn back into your application based on what they see on your tile. And think about how you're going to tie the content in your application to that tile, so the two feel like they're part of the same application, because they are. Use periodic, use push, use scheduled notifications to make your application feel alive. Those are the best ways to keep that tile alive when users aren't directly using your app. And finally, take a look at Windows Azure and the toolkit. It's a great way to get off the ground running. So these are some great resources. Of course, our developer documentation has the best reference set there. The Windows Azure toolkit is available at windows8.codeplex.com. And then the registration site that I pointed to earlier on the build. So with that, I'm done. I appreciate your time. I'll take a few questions and give the next speaker an opportunity to get set up. So if there's any questions, I'd be happy to answer some. Yeah.
So you recommend re-registering a service? Yeah, but almost now, since Windows 8 is supposed to be long running, my computer never reboots. I start mail and it might run for 30 days, so should I re-register more?
That's a good question. So the question is, I said the recommendation of setting up your channel URI to your service whenever your application's launched as a good way to keep it up to date. But in Windows, since we have the Process Lifetime Manager, since your application will actually be effectively suspended in the background, it may not actually be closed. What should you do about that? My recommendation there is, in your app, there's a couple things you can do. One would be to look to send that channel up every time the application is switched to. What I would recommend, though, is that you build some logic in to compare the channel you sent previously successfully to the one that you just got, to make sure you're not spamming your service with egregious re-registrations of the same channel. It's a good idea to filter that at the application level.
So are you saying if I
We do a little bit of caching locally on the client. So if you request the channel repeatedly from us, we're going to actually keep giving you back the same channel for 24 hours. And so if it doesn't change, don't bother sending it up. So don't rely on any particular number. What our advice there is just, if it hasn't changed, don't send it up again. Are there any other questions? All right, great. Well, I appreciate your time. Thank you very much. And I look forward to seeing what you guys do with your apps.